What patterns exist in waves and vibrations? We are surrounded by countless sights and sounds all day long. When we wake up in the morning, sunlight fills our room, and phone notifications and people's voices fill our ears. If we were to close our eyes and cover our ears as well, we would feel an unsettling sense of isolation, as if we were cut off from the world. This is because the most important way humans understand the world is through light and sound. Although light and sound seem completely different, they are both produced by the same phenomenon called waves. Ocean waves, earthquakes, and radio waves used in wireless communication are all waves as well. Waves are often invisible to us, but they move throughout the world and shape our daily lives. So, what exactly is a wave? A wave is a phenomenon in which vibrations at one point spread outward to the surrounding medium. The substance that carries the vibration is called a medium. Sound travels through air, and water waves travel across water. It is similar to a playground, where one person starts running and the movement spreads to others nearby. Waves contain many underlying rules and patterns. The distance between one crest and the next is called the wavelength, and the size of the vibration is called the amplitude. The number of vibrations per second is called frequency, and the time required for one complete vibration is called the period. These rules allow us to distinguish different pitches and loudness in sound. For example, the higher the frequency, the higher the pitch, and the greater the amplitude, the louder the sound. Waves are classified into two types based on how they move. The first type is a transverse wave. In a transverse wave, the vibration moves perpendicular to the direction in which the wave travels. A simple example is the wave created when a jump rope is shaken up and down. The second type is a longitudinal wave. In a longitudinal wave, the vibration moves in the same direction as the wave itself. When a spring is pushed and pulled, regions of compression and expansion form in sequence. This is a longitudinal wave. Sound is a typical example of a longitudinal wave. One of the most remarkable properties of waves is that they do not disappear when they meet. When objects collide, they may break or bounce apart, but waves behave differently. When two waves overlap, their amplitudes combine and may become larger. However, once the overlap passes, each wave continues as if nothing had happened. It is like two people briefly brushing past each other and then continuing on their own paths. Because of this property, multiple radio signals can exist simultaneously, making modern communication technologies possible. Waves can be reflected, transmitted through materials, or sometimes cancel or weaken one another. These properties are essential in modern science and technology. A well-known example is X-rays. X-rays have wavelengths shorter than visible light, allowing them to pass through the human body. Soft tissues such as skin are easily penetrated, while dense structures like bones absorb or block them. This is why X-ray images allow us to see the condition of bones inside the body. Ultrasound is another technology based on wave behavior. Ultrasound refers to sound with a frequency too high for the human ear to hear. When ultrasound is sent into the body, it reflects off the boundaries between organs and tissues. Hospitals analyze the returning signals to create images of the inside of the body. This is also how doctors can observe a fetus in the womb. Waves are also hidden within music. String instruments, such as the violin and guitar, produce sound through vibrating strings. However, the vibration of the string alone is not enough to produce a strong sound, so it is transferred to the body of the instrument, which amplifies the vibrations by moving the surrounding air. Through this process, sound waves reach our ears as rich and beautiful tones. A special type of wave called a standing wave forms on the strings of these instruments. A standing wave is a wave that does not travel forward, but instead oscillates in a fixed position. It is created when a traveling wave reflects at the ends of a string and interferes with itself. As a result, some points on the string remain almost still, while others vibrate strongly. The clear and beautiful sound of string instruments comes from these stable wave patterns. We often think of waves as abstract and difficult scientific concepts, but in fact, waves are all around us. The music we listen to, medical imaging devices, mobile communications, radio, and Wi-Fi all rely on the principles of waves. The world is constantly moving through patterns of vibration and repetition, and mathematics and science help us uncover this invisible order.